Hey everyone. Welcome to Top Tech News. This is your news channel for getting updated with the latest tech news headlines and their impact on business and our lives. To read the full news article for any of the news that we cover, simply click on its link given below in the description. To stay updated, show us some love and hit the subscribe button below and turn on notifications by clicking the bell icon. This way you would be informed whenever we upload a new video. Hi, my name is Dee and I am your host for today. Today's top headlines are: Nvidia to train AI with minimal data. Google improves city GPS accuracy. Oppo's removable camera module patent. Canon's dual-pixel BSI sensor. U.S. Air Force's Skyborg drone on the way. Let's get started. Nvidia to train AI with minimal data. Nvidia has developed a new approach for training generative adversarial networks, GAN, that could one day make them suitable for a greater variety of tasks. Before getting into Nvidia's work, it helps to know a bit about how GANs work. Every GAN consists of two competing neural networks, a generator and a discriminator. In one where the goal of the algorithm is to create new images, the latter is what examines thousands of sample images. It then uses that data to coach its counterpart. In order to create consistently believable results, traditional GANs need somewhere in the range of 50,000 to 100,000 training images. With too few, they tend to run into a problem called overfitting. In those instances, the discriminator doesn't have enough of a base to effectively coach the generator. In the past, one way AI researchers have tried to get around this problem is to use an approach called data augmentation. Using an image algorithm as an example again, in instances where there isn't a lot of material to work with, they would try to get around that problem by creating distorted copies of what is available. Distorting in this case could mean cropping an image, rotating it, or flipping it. The idea here is that the network never sees the same exact image twice. The problem with that approach is that it would lead to a situation in which the GAN would learn to mimic those distortions, instead of creating something new. Nvidia's new Adaptive Discriminator Augmentation, or ADA approach still uses data augmentation but does so adaptively. Instead of distorting images throughout the entire training process, it does selectively and just enough so that the GAN avoids overfitting. The potential outcome of Nvidia's approach is more meaningful than you might think. Training an AI to write a new text-based adventure game is easy because there's so much material for the algorithm to work with. The same is not true for a lot of other tasks. Researchers could turn to GANs for help. For example, training an algorithm to spot a rare neurological brain disorder is difficult precisely because of its rarity. However, a GAN trained with Nvidia's ADA approach could get around that problem. As an added bonus, doctors and researchers could share their findings more easily since they're working from a base of images created by an AI, not patients in the real world. Google improves GPS accuracy. The flaws and constraints of GPS in dense urban environments are well known by anybody that has used Google Maps in cities, especially downtown. Google is now improving GPS, starting on the Pixel 5 and 4a 5G, with the help of 3D mapping. GPS accuracy plummets in dense urban areas due to GPS, which requires line of sight, signals being reflected by high-rise buildings. This manifests as apps showing that you are on the wrong side of the street, or even a different block entirely. The GPS chip assumes that the signal is line of sight and therefore introduces error when it calculates the excess path length that the signal's traveled. Google is addressing this problem with 3D mapping, which features building models aided corrections that account for obstructions and inform the GPS system. The 3D mapping aided corrections module, in Google Play Services, includes tiles of 3D building models that Google has for more than 3,850 cities around the world. When you use your device's GPS while walking, Android's Activity Recognition API will recognize that you are a pedestrian, and if you are in one of the 3,850+ cities, tiles with 3D models will be downloaded and cached on the phone for that city. For example, in this picture of a pedestrian test, the person is carrying a Pixel 5 phone and is walking along one side of the street and then the other. The yellow lines are the lines for the path that was followed, red depict path without 3D mapping aided corrections, while blue shows the path with 3D mapping aided corrections. This is first launching on the Pixel 5 and Pixel 4a 5G with this month's security update. Google says that version 2 of this system reduces wrong side of street occurrences by approximately 75%. Other Android phones using Android 8 or later have version 1 implemented in the FLP, which reduces wrong side of street occurrences by approximately 50%. Version 2 will be available to the entire Android ecosystem, Android 8 or later, in early 2021. After the latest Pixel devices, This feature is rolling out via Play services to Android 8 Plus devices over the next several weeks. Google is also working on implementing this capability when driving. The new feature works with Global Positioning System, GPS, GLONASS, Galileo, Beidou, and QZSS. It's available in the following regions: North America, all major cities in USA, Canada, Mexico. Europe, all major cities. 100% except Russia and Ukraine. Asia, all major cities in Japan and Taiwan. Rest of the world, all major cities in Brazil, Argentina, Australia, New Zealand, and South Africa. Google touts 3D mapping aided corrections as something that only it could achieve due to its collection of 3D building models, raw GPS measurements, and machine learning. Oppo's patented smartphone with removable camera. Needing to use a lower resolution front-facing smartphone camera for selfies and video calls might be a thing of the past if Oppo acts on a recently filed patent. The design within features a rear camera module that separates from the main camera body. Oppo's patent depicts how the rectangular module would detach from the rear of the camera and attach to the USB-C terminal at the bottom of the phone. The male USB-C plug would flip out from the bottom of the camera module and is able to bend at both 90 and 180 degrees. The camera module itself appears to show two camera sensors as well as an LED flash. If needing to connect the module directly to the camera feels dated, not to worry. The patent also describes Wi-Fi, Bluetooth, and NFC connectivity for remote connections. If there is an advantage to using the physical attachment or a disadvantage to going wireless, it's not mentioned in the filing. In addition to theoretically giving you the ability to detach the module, set it down, stand in front of it, and then fire it with your phone for selfies that wouldn't just be from the perspective of the phone in your hand, the design also opens up the possibility of additional modules that could be upgraded over time or have specialized uses, like a lower resolution low light camera, or super high resolution camera upgrades. While photographers are familiar with the idea of their cameras having multiple parts, it's unclear if the general consumer who only uses their smartphone for their limited photography would find a design like Oppo's useful. The main appeal of smartphones is their no-brainer ease of use, and complicating that might not be of interest to a wide market. Just because Oppo patented this design doesn't mean we will ever see it in a finished product. Even if we do, it might take some time. So don't hold your breath yet on this. Canon's dual-pixel BSI sensor. Canon has patented a new sensor design that mimics the design of backside illuminated, or BSI, sensors made by Sony. Mixing dual-pixel with BSI would likely result in huge leaps in low-light performance, dynamic range, and readout speeds. The design illustrated in Canon's patent application does not specifically state that it would be a backside illuminated, but when compared to a figure of a BSI sensor, the similarities are impossible to ignore. In this picture from Sony, the company shows how a BSI is constructed. Sony developed this type of CMOS sensor back in 2008. Reports that Canon has been attempting a design like this go back as far as January of 2019, but a dual-pixel BSI were only mentioned, not truly depicted in detail like is seen in this patent. Basically, rather than constructing a sensor akin to how the human eye works, which places the lens in front of the wiring, with photodetectors in the back, a BSI uses the same elements but rearranges them so that the photodiode can exist in front of the wiring. With the typical front-side illumination method, the matrix and the wiring reflect some light which reduces the signal that is able to be captured. BSI sensors alleviate this at the cost of worse response uniformity but gain far better low-light performance. BSI sensors have become the norm for improving low-light performance and improving dynamic range, but they have an additional benefit of a boost to readout speeds. The reason the Sony A9 is capable of firing so many frames per second in a fully electronic, silent, blackout-free mode is in part thanks to the benefits of the stacked BSI CMOS it is equipped with. Sony does have additional technology that pulls information off the sensor twice as fast as competitors, but the benefits of the BSI sensor can't be fully disregarded here. Looking more closely at Canon's patent, the structure depicted is strikingly similar to a BSI diagram. Canon is one of the only companies that is not using Sony sensor technology in its cameras, hence why a BSI in a Canon camera has yet to happen. Even without BSI sensors, Canon has already dramatically improved the dynamic range and low-light performance of its cameras as seen in the R5 and R6. What the company could do with this latest patent tech opens the door wide for true competition with the industry leader. Combining Canon's dual-pixel autofocus technology with a backside illuminated design would result in a sensor that may finally be able to stand toe-to-toe with Sony's best. Such a sensor design would be critically important to producing a low light leader like the A7S III or a mirrorless sports camera like the A9. U.S. Air Force's Skyborg drone on the way. Boeing, General Atomics and Kratos will create prototypes for the U.S. Air Force's Skyborg program and have a mere 5 months to build the first test vehicles of the autonomous combat drone. As part of the Skyborg program, the Air Force hopes to build a family of low-cost, attritable drones that can be reused, but are cheap enough that losses in combat can be financially and operationally tolerated. The project is meant to produce a family of uncrewed aerial systems that can move into contested spaces and conduct aerial missions that might be too dangerous for human pilots to perform. The Air Force announced contract awards on 7 December for the 3 companies that will produce prototypes for the air vehicle portion of Skyborg and compete in a series of experiments in the hopes of winning a production contract. Military officials expect the first prototypes to be delivered no later than May 2021 for initial flight tests. The prototypes will then proceed into flight experiments beginning in July 2021 that will test each drone's ability to team with manned aircraft, the service stated in a news release. One key differentiator between Skyborg and past combat drone programs is the development of artificial intelligence that will allow the aircraft to operate autonomously and potentially learn from prior training missions. Over the past several months, the program has focused on developing the technologies necessary for the autonomous core system, the hardware and software that will enable the Skyborg drone to operate semi-independently from a human operator who will be able to issue commands but will not have to physically fly the system. The system is being designed by Leidos, using input from the Air Force and other Skyborg vendors. After prototypes are delivered, the Air Force will outfit them with that autonomy module. The 3 prototype manufacturers must also prove their aircraft is capable of incorporating payloads and mission systems being supplied by the other 10 companies on contract to potentially supply capabilities for the Skyborg program. In July and September, the Air Force awarded indefinite delivery, indefinite quantity contract worth up to $400 million to establish a pool of 13 vendors that would compete to offer Skyborg hardware and software, everything from the drones themselves to sensors, weapons, and algorithms. With a name like Skyborg and planned AI that will allow the aircraft to operate autonomously and learn from its past missions, we aren't sure if this is going to end up nicely. At least for us humans before our AI overlords take over. Guess these guys didn't watch any of the Terminator movies. Well, that's about it for today. Hope you found it helpful. Let us know your thoughts in the comments below and don't forget to subscribe and turn on notifications by clicking the bell icon. And do show us some love by clicking on the thumbs up button. Have a wonderful day everyone, and we will be back again soon.